Hi everyone, I am Ludovic Javet, one of the co-authors of the paper entitled Pushing Edge Computing One Step Further, Resilient and Privacy-Preserving Processing on Personal Devices. Let's start with the context. With the explosion in the number of connected devices over the last decade, the usual reliable and server-based data management approach is now exhibiting its limits in terms of efficiency, privacy, and energy consumption. A game changer is the generalization of trusted execution environment. They are secure hardware widely used in personal devices, ensuring the integrity of the device's software and the confidentiality of the manipulated data. Our goal is to leverage the trusted execution environments to propose fully decentralized execution strategies that enable privacy-preserving sample-based queries while providing fault and disconnection tolerance. Thus, in this application of Edgelet computing, we demonstrate the overcollection strategy, which makes the execution tolerant to failures and temporary disconnections. We also illustrate the privacy aspect of the approach with its data distribution mechanisms and its generosity with computation ranging from simple statistics to machine learning. To understand the overall process, let's first configure a new Edgelet query. The query execution is fully decentralized and performed only by secure personal devices, the edgelets, which act as data contributors or data processors. A query execution plan is a tree, with data contributors at the leaves sending the requested data to snapshot builders. They collect a representative snapshot and send it to computers. Then, the computers perform the processing and deliver the result to the querier through computing combiners which merge the intermediate results. We consider a query that computes several group-by clauses on the same cohort of individuals. For instance, the average physical and mental health grouped by age category then by alcohol drinking. To meet the privacy needs of the data contributors and reduce the impact of data leakage in case of compromise, we can limit the amount of raw data manipulated by each node. Another way to adjust the privacy level is to choose a set of attributes that should not be found together in the same computer device. For instance, different computers will perform processing on age category and alcohol drinking. The query plan is then automatically adapted to these new restrictions. Finally, we can see that the execution tree incorporates another collection strategy to overcome the edge failures as well as disconnections. In a nutshell, we use the distributive feature of queries to add additional partitions, as it can be seen in blue on the figure. Using the graphical interface, we can select the node which will be executed on real secure personal devices. For example, a personal computer equipped with Intel SGX or a home box equipped with a trusted platform module. The rest of the operators are associated with simulated edgelets to attest the scalability of the approach. Now, let's move on to the execution. The data are filtered by the snapshot builders to be representative of a desired sample. We can check that the computers dealing respectively with age category and alcohol drinking can only see the necessary attributes. The aggregates are then sent to the computing combiners to produce the final result. Let's now study an iterative algorithm, taking K-means as an example. We are interested in grouping thousands of individuals into 4 clusters. To enforce privacy, we limit the maximum number of data per node to 200. Let's see how K-means works with overcollection. Initially, each computer receives a partition of the dataset from the snapshot builders. Then, the computers execute the K-means locally until a heartbeat, that is, a synchronization time. At heartbeat, each computer sends centroids to other computers and computes the barycenter of all received centroids. After a certain number of iterations, the computers send the centroids to the computing combiners. The demonstration platform allows to look at the position of the centroids at each heartbeat of the K-means algorithm. We see that iteration after iteration, the exchanged centroids make the computers converge toward the same clusters, and this despite failures and disconnections. We can also see that the data are well collected on each computer, which allows to perform statistical computations on the cluster formed. In conclusion, this demonstration built on real secure personal devices shows the practical interest of edge computing, both in terms of computational generosity, but also in terms of privacy and resiliency. Thanks for your attention.